We know the Taylor series for e to the x, for cosine x, and for sine x. They converge for all values of x. And if we look at them closely, we see that there is some relationship between them. So if you look at cosine x, it has a term 1, which e to the x has. It has a term x squared over 2 factorial, which e to the x has. X to the 4th over 4 factorial, which e to the x has. The main difference then is that cosine x is missing the odd powers of x, and it has alternating signs. But sine x has the odd powers of x and also has alternating signs. So it kind of makes us think maybe there's a relationship between these three functions. And in fact, there is a very important relationship between them. And the only way we can see the relationship is to use complex numbers. So let's look at the function e to the ix. So remember, I is the square root of -1. If we just plug it into the Taylor series, we get 1 plus ix plus ix squared over 2 factorial plus ix cubed over 3 factorial. And we keep going, plus ix to the 4th over 4 factorial plus ix to the 5th over 5 factorial, and so on. We would like to write this now in the standard complex number form as a real part plus I times an imaginary part. And we can make use of what we know about powers of I. So I squared is -1. I cubed is I times -1, so it's minus I. And I to the 4th is I squared times I squared, which is +1. So the powers will alternate between 1, I, -1, minus I, and then back to 1 again. So let's write this now as a real part. So the real terms here would be 1. Ix has an I in it, but I squared has a -1. So the second term will be minus x squared over 2 factorial. I cubed has a minus I in it, but I to the 4th is a +1. So the third term here is x to the 4th over 4 factorial. And then the sign changes again. So this is the first piece. Then the second piece has a multiplication by I. And what will that be? The leading order term will be x from ix. The next term will be from I cubed. So I cubed is I times -1. So that will be I times -1. So that would be minus x cubed over 3 factorial. The next term will be I to the 5th, which is I to the 4th, which is 1 times I. So it's plus I. So it's plus x to the 5th over 5 factorial, and then so on. And now we have a connection between cosine, the first series here is the cosine series, and sine, the second series here is the sine, and the complex exponential function. So we get the amazing result that e to the ix is equal to cosine x plus I sine x. And that is maybe one of the most remarkable formulas in mathematics. That's called Euler's formula, after Euler. Okay, amazing result that we obtained from the Taylor series. This gives us e to the ix. So let me write that up here. So we have e to the ix is cosine x plus I sine x. If we change the sign of x, we can write e to the minus ix. Cosine is an even function of x, so cosine x. Sine x is an odd function of x, so we get minus I sine x. And then we can use these two expressions to derive a formula for cosine and sine in terms of the exponential function. So if we add them, the sine x cancels, and we divide by 2, we get cosine x is equal to e to the ix plus e to the minus ix divided by 2. And if we subtract them, so we end up with 2i times sine x, and divide by 2i, we'll get sine x is equal to e to the ix minus e to the minus ix divided by 2i. So now we have a relationship for the complex exponential in terms of cosine and sine, and we also have a relationship for cosine and sine in terms of the complex exponentials. Amazing results. There's one more formula I want to show you, which is just for fun. If we look at e to the ix equals cosine x plus I sine x, and we plug in x equal to pi, then we would get e to the I pi equals cosine pi. Cosine pi is -1 plus I sine pi. Sine pi is 0. So then if we write this in a more t-shirt friendly way, we would get e to the I pi plus 1 equals 0. That's called Euler's identity, and it's one of my favorite equations or identities in mathematics because it relates in one equation the 0, which is the addition identity, the 1, which is the multiplication identity, I, which introduces complex numbers, and the two transcendental numbers, pi from trigonometry and e from calculus. And in one equation with one addition, plus here, one multiplication, I times pi, and one exponentiation, e to the I pi. Put that on a t-shirt and wear it. So let me summarize. We've now, using the Taylor series for the exponential function, the cosine and the sine, derived one of the most important identities in mathematics. E to the ix equals cosine x plus I sine x. Using that identity, we can then write cosine x as e to the ix plus e to the minus ix over 2, and sine x as e to the ix minus e to the minus ix over 2i. I'm Jeff Chasnoff. Thanks for watching, and I'll see you in the next video.